Hello, my name is Mrs. Kershaw and welcome to today's lesson about strong and weak acids. This is a lesson for higher tier students only, following both the combined science pathway and the chemistry pathway. Before we start today's lesson, you will need a pen, some paper and exercise book, and unless you're viewing this video on a mobile phone, turn off all mobile phones and remove any distractions. So let's begin. Our challenge today will be to describe the difference between strong and weak acids, and our aspire is to explain the difference between acid strength and concentration. First of all then, let's have a little recall on the previous lesson and see what you can remember about acids and bases. I'm going to give you 2 minutes. Okay, let's see how you got on then. So all acids contain positive hydrogen ions. Bases will contain negative hydroxide ions. During neutralization reactions, these combine to form water. Strong acids have a pH of 1, 2 or 3, and an example of a strong acid is hydrochloric acid. Okay then, so just reminding you from last lesson when we looked at the pH scale, then strong acids are found to the left of the pH scale and have pHs of 1, 2 or 3. Neutral has a pH of 7. Strong alkalis are 12, 13 and 14. Examples of strong acids are stomach acid. Weaker acid is lemon juice, which contains citric acid. Water has a pH of 7, so it's neutral. Soap contains a weak alkali, so it is 8 or 9. Baking powder, slightly stronger alkali then, and then the most strong alkali that you would have in your house would be oven cleaner. Universal indicator will tell us how strong an acid or an alkali is. So on our recall starter, we talked about the fact that all acids produce hydrogen ions when they are dissolved in water. Just a reminder then that when something is dissolved in water, we call that an aqueous solution, and that would be signified in the reaction with the letters AQ in brackets after the substance which has been dissolved in water. Here we have the example of hydrochloric acid, which when it dissolves in water produces the H plus ion and the Cl minus ion. And the H plus ion is produced because the acid molecules ionize, that means they split up and release the H plus ions. Just a reminder from previous lessons then, that ionize means to gain a charge due to the loss or gain of electrons. So charged particles are called ions. Looking at that hydrogen ion then, so when a hydrogen atom loses an electron to become a hydrogen ion, all that's left then would be a proton. Now sometimes in textbooks you may see acids described as proton donors, and that is because when they are dissolved in water they produce the hydrogen ion, which essentially is a proton. We decide how strong an acid is by the extent to which they ionize in water. Strong acids will fully ionize in water. That means that all the acid particles dissociate, that means separate, to release H plus ions. Examples of strong acids are hydrochloric acid, sulfuric acid, nitric acid. You will be expected to know the formulas of each of these acids. Lots of hydrogen ions means that the acid will react quickly, as lots of collisions can occur. And if we look at that pictorially, then a sulfuric acid molecule, once you put it in water, will dissociate to produce those two H pluses that you can see on the right hand side and the sulfate ion. So just go through the examples of strong acids that you are expected to know. They are hydrochloric acid, HCl, sulfuric acid, H2SO4, and nitric acid, HNO3. If we now look at weak acids then, weak acids only partially ionize in water. That means that only a small proportion of acid particles will dissociate, that means separate, to release hydrogen ions. Examples of weak acids that you are expected to know are ethanoic acid, otherwise known as vinegar, citric acid, which is found in citrus fruits, and carbonic acid, which is formed when carbon dioxide dissolves in water. In these reactions, an equilibrium reaction occurs, with the equilibrium reaction displaced towards the left. That means it contains the same amount of acid molecules, but it will have fewer hydrogen ions released. If we look at this pictorially then, you can see ethanoic acid shown on the illustration, and this will partially dissociate to produce the ethanoate ion and hydrogen ions. But it's an equilibrium reaction, so you will always have both the reactants and the products present, and that means you will not release as many hydrogen ions as you will do with a strong acid. So just going through those examples of weak acids again then. So you might have something called carbonic acid, which is what's formed when carbon dioxide dissolves in water, so you might find that in fizzy drinks. Ethanoic acid, otherwise known as vinegar, and citric acid, which you find in citrus fruits such as lemons. On this slide then, first of all we have a strong acid, and you can see in this case that all the acid particles have dissociated into their ions, generating lots of H plus ions. So this is a strong acid forming lots of H plus ions where all the molecules are ionized. If we compare that then to a weak acid on the right, you can see that in this diagram some of the particles have dissociated to form ions, but some of them have stayed together as their molecule. And this is an example of a weak acid where only a small fraction of the molecules ionize. So let's compare the reactions of strong and weak acids. First of all, let's look at the reaction of magnesium with hydrochloric acid, a strong acid. If we then compare this to the reaction of magnesium with a weak acid, such as ethanoic acid, we can see that in this case the reaction is much less vigorous. So let's see how we're getting on then. So I've got 3 questions for you. The first one is, what is the difference between a strong and a weak acid? Can you give 2 examples of strong acids? And can you give 2 examples of weak acids? And I'm going to give you 3 minutes to complete those questions. Right, let's grab a red pen and see how you got on. If you need to pause the video at this point to modify or add to your answers, then please do so. What is the difference between a strong and a weak acid then? Strong acids will fully ionize in water to release H+ ions. Weak acids only partially ionize in water to release H+ ions. Two examples of strong acids then, you could have any from hydrochloric acid, sulfuric acid and nitric acid. And two examples of weak acids then, you could have had citric acid, ethanoic acid or carbonic acid. Back to universal indicator and the pH scale then. So we know where our strong and our weak acids are, we know where neutral is, and we know examples of them. We also now know that strong acids fully dissociate to produce hydrogen ions in water, whereas weak acids only partially dissociate. We need to now look at then where the numbers from the pH scale come from. So the pH scale is actually a measure of the concentration of hydrogen ions produced by an acid. But as the pH scale decreases by 1 unit, the concentration of hydrogen ions will increase by 10 times. So what does that mean then? Well, an acid that has a pH 4 has 10 times the concentration of hydrogen ions than an acid of pH 5. Let's look at this with an illustration. So if a solution has 10,000 hydrogen ions in pH 1, how many hydrogen ions will it have at pH 2? Well, we know that pH 1 to pH 2 is a decrease in the strength of the acid. So if the pH of 1 has 10,000 hydrogen ions, then we have to divide by 10 to decrease the concentration of hydrogen ions by 1 odd of magnitude. This means that pH 2 will have 1,000 hydrogen ions compared to the 10,000 that are in pH 1. I'd now like you to have a go at thinking about one of these. So if a solution has 10,000 hydrogen ions in it and it is pH 1, how many hydrogen ions will it have in pH 3? 30 seconds to have a think about that. Let's see how you get on then. So if the solution has 10,000 hydrogen ions at pH 1 and we are going to pH 3, that's 2 orders of magnitude that we've changed, going from 1 to 3. So this time we would need to divide by 100. So if we divide 10,000 by 100, we get 100 hydrogen ions. Let's try another one then. So if a solution has 1,000 hydrogen ions at pH 2, how many hydrogen ions will it have in pH 4? 30 seconds. How do we get on then? So if a solution has 1,000 hydrogen ions in pH 2, how many hydrogen ions will it have in pH 4? We've gone from pH 2 to pH 4. We had 1,000 hydrogen ions, and this time we've changed by 2 orders of magnitude again. So we will this time would again divide by 100. So 1000 divided by 100 would give us 10 hydrogen ions. So as a general rule then, the factor of hydrogen ion concentration changes by 10 to the minus x if x is the difference in pH. So if the pH falls from 7 to 4, the difference is minus 3. And if we look at that mathematically then, the factor of hydrogen ions concentration has increased by 10 to the minus 3. Minus times the minus is a plus, so it's changed by a factor of 10 to the power of 3. Okay, let's have a look at some stretch and challenge then. So a student added strong acid to a weakly acidic solution that was originally pH 6. The new pH of the solution was found to be pH 2. So we need to calculate the number of times the concentration of hydrogen ions has increased. I'm going to give you a minute to do that. Okay, so going back to the question then, a student added strong acid to the weak acid solution. So this time we have changed by minus 4. So we started at 6, we went to 2, and if we minus those we get minus 4. This means that we've changed by a power of minus 4. So this gives us a change factor of 10 to the power of 4. So it will have increased by 10,000. Quick progress check now then, looking at an exam question that's previously been set. Here we have 10 centimetres cubed of solution B is added to a beaker. Distilled water is added to the beaker until the final volume of the beaker is 1000 centimetres cubed. So we started at 10 centimetres cubed and the pH of the solution was 3, and then we've added water until the beaker becomes full at 1000 centimetres cubed. So you need to now work out the pH of the final solution. 2 minutes. Okay then. So we started off at 10, and if we went to 100, that would be a reduction of a factor of 10. However, we actually went to 1,000, which is another factor of 10. So this has been a change of 2 factors of 10. That means the pH will have increased by 2, so the pH will be pH 5. So far we've talked about the strength of an acid, but what do we mean by the concentration of an acid? Because these things are quite different. So if we've got a strong or a weak acid, we know that that means they are fully or partially ionized. But concentration is something quite different. Concentration tells us the amount of acid molecules in a given volume of solution. A dilute acid will have fewer acid molecules in a given volume than a concentrated acid, even if the strength of the acid is the same. Looking at Ribena then, just to illustrate concentration, on the left we have dilute Ribena, which will have very few Ribena particles in it, but on the right we have concentrated Ribena, which will have lots of Ribena particles in it. Acids are very similar. So thinking about acid concentration, in a dilute acid there will be less acid particles. In a concentrated acid there will be more acid particles. I'm thinking about the strong acid that we looked at earlier, hydrochloric acid. You can see on both of these diagrams the particles are fully ionized, so this is a strong acid. However, the one on the right has less particles, so therefore it is dilute, whereas the one on the left is concentrated because it has more particles. Remember, this is a strong acid as all the particles have fully dissociated. Let's summarize then the acid strength versus the acid concentration. The first thing to remember then is they are not the same thing. Acid strength and acid concentration are two different things. The concentration tells us how many moles of an acid there are in a decimeter cubed of solution, or how many particles there are in a given volume. The strength of an acid tells us how much it has ionized. This means that a strong acid can be diluted to obtain a pH similar to that of a weak acid. However, in a weak acid, as the hydrogen ions are used up, the non-ionized weak acid particles will produce more particles. A weak acid can react many times more with reactants than the same volume of a dilute strong acid. And just to look then at how concentration affects the rate of a reaction, let us summarise this pictorially then. So in our first diagram we have a strong acid, and we can see this because all the particles have fully dissociated. If we compare this to our weak acid then, here we can see that only some of the particles have dissociated. If we then look at concentration, here we can see that we've still got a strong acid, but it is dilute. Only a small amount of acid is dissolved in the water. If we compare this then to our dilute weak acid, again we've got less particles in the water, but it's a weak acid because it's only partially dissociated. Let's check our understanding then. So here's an exam question which asks you to explain why an acid can be described as both strong and dilute. And at this point, I'd like to remind you that in an explain question, we need to give a reason why something has happened, and a good connective to use is the word because. I'm going to give you 2 minutes to attempt this question. Okay, let's grab a different colour pen, and if at any point you need to pause the video, please do so and modify your answers. So explain why an acid can be described as both strong and dilute. It can be strong because it's completely ionised, and it can be dilute because only a small amount of acid is present per unit volume. Okay, that's the end of today's lesson then. So the following slides will have a summary of what we've covered today. If you'd like to pause the video and write any additional notes in your book, then please do so.